Hey everybody, welcome to week 14. We have made it to the end of the semester. So this is going to be the last live stream lecture for spring 2021. So I hope it's been a fun ride. And hey Andre, hey Dimitri, welcome. So we are going to do some miscellaneous tips and tricks, sort of problem solving based on some student questions I got over the past week. And thank you to those who submitted some student questions. They were all pretty good. All right, so first one. One person asked about, I'm curious about creating a countdown box that shows the seconds until the next event is automatically triggered. Thinking of different ways for triggering, especially since using a MIDI USB pedal is difficult for a vibraphonist to use. This is a nice idea, right? For like pianists, vibraphonists who the performance of their instrument kind of relies on their feet as well as their hands. Using a pedal is a little bit more complicated for someone like a flutist or a clarinetist or someone who does a feet-free instrument. So I cooked up a little solution here as kind of a starting point. It's not perfect, but I think it gets the job done. So the first thing I have done here is I make myself a window. And on that window, I create a number box, which fills the entire window. And then I just set some visual attributes here. So background color, the color of the number displayed in the box, the font, and we've seen this before, but just, font. The font object needs two things, a font name and a font size. And rather than put specific names in here, I usually just go with one of these class methods like default sans face, default serif face, default mono face, just to guarantee that it's a valid font. And this was kind of the discovery as time string. So if we say 0.as time string, it gives us the string 00:00:00, etc. So I think this is hours, minutes, seconds, and then fractions of a second. So if we do something like 10,000, that is 2 hours, 46 minutes, and 40 seconds. So it does all the work for us, which is great. I mean, this is like probably would have been the most annoying part of this, but this is handled for us. And the keep 10 is a method for sequenceable collection. And basically what keep does is it starts at the beginning and keeps this many items in the collection and just removes the rest. And so this just has the effect of not being quite so precise with the fractions of a second. I thought it was a little bit excessive to display all this precision. And maybe there's a nice way to do this where you actually can display precise time, but SuperCollider is not really optimized for visuals, and so I'm hesitant to ask it to update the GUI every 100th of a second or even 1,000th. So I figure, forget about it. 10th of a second is probably good enough for us. And then I also don't want it to focus. Just there was like a little blue background. You don't even need this step, really. You can make it focusable if you want. Doesn't really matter. So here we go. So here's our nice little countdown timer. And then what I did, so we will actually make a very, very, very simple piece. So we have a wait for boot function, and in that wait for boot function, we're going to make a very basic instrument, ultra simple, just play a tone with a percussive envelope, panned. And then what we're going to do is make a routine. And actually, let's just forget about these for now. So this is, ultra simple, stripped down version of what some performance code might look like. So we could, run this. It's going to boot the server and just ignore that warning. That's from me just messing around earlier. And then we can just say, P equals P stop play. And so it plays a tone at 400 hertz. It's going to wait for 8 seconds because it's playing on the default tempo clock. 700 hertz. It waits for 5 seconds, and then it's going to finish out this truly, truly amazing piece with a 250 hertz tone. And the crowd goes wild. It's amazing. All right, so the last step here is to write some function which is responsible for setting a starting time on this GUI number box and then running some routine which counts down to 0. So I'm going to call that start countdown. It's going to be just a regular function. And so we might ask ourselves, what kinds of things do we want to pass to this function? Certainly we want the amount of time. And we probably could stop there, but I also thought it made sense to, excuse me, pass in the instance of number box, just in case maybe you had some piece where you had multiple countdown timers and you wanted to set one of them specifically. I guess this is kind of rare, so you could probably skip this step if you wanted. I just thought I'm trying to keep this function as modular as possible, flexible as possible. So we'll pass in the time we want to count down from and the number box to use for displaying the countdown. And we're going to have some sort of countdown routine. And we're going to play this on, you know, we could say the default tempo clock if we wanted, because we know, well, unless we've messed with it, it's going to be 1 beat per second, but we could even just be extra clear. And we just play it immediately. This is going to guarantee that beats equals seconds, because we're thinking in terms of seconds here. And in this routine, we're going to do a while loop. And while works like this: test function and function to evaluate if true. It's very easy to get stuck inside of a while loop, so you want to be careful here. We're going to say while time is greater than or equal to 0. Right? That means there's still time on the clock. And if that's true, then, do the thing, basically. And so here we're going to say number box. Sorry, that's NB for number box. Dot string is time dot as time string dot keep 10. And we have to, we'll stop there for a second. I think there's a little bit more we have to do. And then we're going to say time equals time minus the increment. And since 0.1 is the smallest increment here, I think we'll do that. And we don't want it to go below 0. And so max will take the greater of its receiver and its argument. So if this value is positive, it'll use this value. If we have time is equal to 0 and it goes down to negative, it's going to say, no, we're going to use 0 because that is greater. That's the maximum of those two values. Because I don't want to see a negative sign pop up here on the countdown timer. And then, very important, we wait. Gotta wait. Otherwise, it's just going to blast through this countdown as fast as possible. Okay. And I think this ought to work. Well, it's actually not going to work, I don't think. But like, well, let's just run this. What did I mess up here? Oh, I need a comma. The test function and the performing function need to be separated by a comma. Okay, so that works just fine. And if we just sort of test our countdown function now, this number box is called n. So we pass in the time, 10 seconds, and this is going to give us an error, I think. Yeah. So this error, you cannot use this Qt functionality in the current thread. Try scheduling on app clock. We're playing on a tempo clock, but it's talking to GUI objects. So we could play this on app clock. I think that would be fine. You could just replace tempo clock with app clock. In fact, I want to see if that would work. Try that. Try this. Okay, so that seems to work. But I think I tested this earlier. It wasn't quite so precise. So what I prefer to do is wrap the problem code in curly braces and say dot defer. And when this routine runs into this line, it says, okay, I'm not allowed to do this on tempo clock, so it passes it to the app clock and says, here, you handle this. So this will also work. And so it counts down, and when time gets down to 0, or gets less than 0, this function returns false, and so it passes through it says, okay, I'm done with this while loop. So now we can insert this code right here. Like so. And that should do it. So now if we play this piece routine, we'll hear 400 hertz. The countdown will begin at 8 seconds, and the routine will also be waiting for 8 seconds. It gets to 0, plays the next thing. So this is a nice visual cue. Oh, it didn't work. Why not? Hold on a second. Countdown. Oh, it's start countdown. I'm using the wrong routine here. Okay, this will work. Aha. Here's the problem. Yeah, so once it got to the second routine, it was kind of doing two things at once. It was counting down from 5, but this first routine was still going. And it was saying, you know, not exactly sure, but it was just continuing to set the value to 0, so it was fighting with itself. So I believe we can fix this by just saying countdown.stop. So whenever we run start countdown, you know, evaluate that function, the first thing it's going to do is stop the thing called countdown. This works with nil. Yeah, so on the first pass, it has no problem. It's not going to complain. But it also works if it's a routine. So it'll stop the routine if it's playing and then start a new one. So that, I think, is the final touch. And then this should work. Yeah. So there you go. There's a little yes, actually, I think, Andre, you are right. That might also work, because then it will be equal to 0. And I think the routine will end. That's right, because max 0 is keeping it at 0. So this is actually still true. So I think that will also work. But then you might run into problems if the time is not a multiple of 0.1, like something like that. Then, you know, so, but I think you are ultimately correct, and that would also fix the problem. This is the kind of thing where, like, this is a pretty simple version. I think there are problems with this. Like, you would run into issues depending on the nature of your specific piece and your event structure. I also think this is a little bit messy using an environment variable, because if you had multiple number boxes with separate independent countdowns, this function would be using the same container for routines. So you wouldn't be able to have two countdowns happening simultaneously. I guess if that becomes the case, then you would just need to maintain a collection of multiple countdown routines. There's always a solution. This needs to just kind of grow in complexity depending on what you need. But anyway, I think this is a reasonable place to start. Right? Works, does the countdown. The player can very clearly see when we're going to hit 0, and then they can, you know, and bang. There it is. All right, so we're just going to command period on that and move on to the next question, which is this one from another student, scheduling GUI stuff on app clock. So I put this one next because it is kind of related to what we just did. Using app clock to schedule the creation of some buttons and windows and probably some animations as well. I've run into issues with some scheduled events being repeated when I wasn't specifically wanting them to repeat. So here's another window. Just making a square black window, always on top, so I don't have to click back and forth. Stuff we've seen, right? It's got an almost black background, put it on the front, no problem there. And then what I have here is another function called make, which, and what happens in this function is we create a view. And a view is just like the sort of most neutral, plain, vanilla GUI object. Doesn't really do anything, but it's got all of the usual attributes like a background color and a size and a position and stuff like that. So we put a view on the window. It's going to have a random XY position, and it's always going to be 30 by 30 pixels, and it's going to have a random color. So it basically just puts a little square on the canvas. So we can just say make that value, bang, bang, bang. So I'm just using this as a test function to work with app clock, and so we can actually schedule this function to happen. Also, keep in mind we can just say make dot and then parentheses. That's a little shortcut, a little bit shorter than typing dot value. Okay, let's start again. Got our function. So the simplest use of app clock is the sched method. I think system clock and tempo clock have sched abs, which allows you to schedule on an absolute beat, sort of, beat 25 or beat 131 or something like that. App clock doesn't do that. It only allows you to schedule relative to now. And so that's what this delta means. So 0 means 0 seconds relative to now. And item is the function that you want to schedule at that time. So this will be exactly the same as what we just did. It just schedules on the app clock the function make at time 0 relative to right now. So we could also say 2 and run this 1, 2. And so that's basic use of app clock here. So then here, sometimes you schedule some function on app clock and you want that function to be rescheduled at some regular or irregular time interval. So you schedule it once, but it happens again and again and again and again. Like if you want to make a row of buttons like turn on or animate or something like that. And to do that, the function that you are scheduling should end with some value, a float or an integer. And if that is the case, then the function will be executed, at initially scheduled based on this delta time. And then when it is scheduled, it will be rescheduled a number of seconds later based on what that function returns. So in this case, it'll be rescheduled every half second. So it'll wait 2 seconds, and then it'll start making squares twice per second. And so now the question is, how do we get it to stop? Because it's just going to keep doing this. One instinct might be to delete this and reevaluate the function, but that doesn't work because when we actually scheduled the function on app clock, it had a different definition. It actually returned a value of 0.5. And so that is kind of permanently baked into the scheduler. Even if we change the function, it's too late. It's already been scheduled as a different function. So a hard stop here is, well, you can hit command period. That will work because one of the many things that command period does is it removes all of the scheduled functions from, I think, all 3 clocks or all clocks, something like that. But you can also say appclock.clear, and that will wipe the scheduling queue out from app clock. And so it just says but this has the effect of removing all registered functions. If we want to specifically remove this one, we have to do a little bit more work. And there's a little trick here, which I think is very clever. So we'll just copy this, make our window. And we'll put 0.5 here. And instead of just scheduling the function make, we're going to schedule a function that is the evaluation of the make function, right? So we're not scheduling make anymore. We're scheduling this function, right? So every time it gets rescheduled, it's actually going to reevaluate the make function. So now we can dynamically change this, and it'll take effect. So if we do this, 2 seconds from now, it'll start making squares. And now we can actually go ahead and change this. Like we'll say make them faster, right? So now they're doing 10 per second. And if we remove this, it stops because this function no longer returns a number. What it returns is a view, right? The instance of the view class that's created. Right. So if we wanted to do a specific number of reschedules, like let's say we wanted to like schedule it once and have it make 20 squares. What we should do there is give ourselves a count variable like this. And then at the bottom of the make function, we're going to do this. So it makes a square, increments the counter, and then it says if count is greater than 20, return nothing, right? Nil is not a number, so that's going to tell the app clock, don't reschedule this. But if it's not 20 yet, 0.1, which means it's going to be rescheduled 1/10 of a second later. This is a slightly different syntax that I'm starting to prefer this one. Usually we do this syntax, putting, if parentheses, condition, comma, function for true, false. I've seen this too. I think this is a little bit more consistent with like other languages, like maybe Java and C++. I don't actually know, but it's the same thing. It's just a different syntax. So now we'll schedule this, and it'll make 20 squares and then stop. Right. So we just put a little counter in there. And so the last thing I want to say on this is probably with regard to the question, which was sometimes things are getting rescheduled when you don't want them to. I have a guess as to why this is happening. And my guess is that you are using number.do in here. So if we say for.do, like this, let's say 1.do. Let's do 2.do. I'm very indecisive. Reset our window, and so here we go with make. And so this might look kind of confusing because in our make function, it looks like we're not finishing with a number, and so you might think, why is it rescheduling? And the answer is that do, it's very easy to forget that do returns its receiver. So this expression actually returns the number 2. This is just a side effect of how do behaves. Doesn't matter what happens in the function. I mean, that the function is evaluated, but if we were, what this expression actually returns is the receiver, which is the number 2, which is why it gets rescheduled every 2 seconds. So it is always a good idea to be extra explicit, and at the bottom of your function to be scheduled, put nil as the last statement if you don't want it to be rescheduled, and put a value if you do want it to be rescheduled, or do some incrementing and conditional check. So this, if we reset this, run this, it's got, now this function actually returns nil. So it'll just wait 2 seconds, make 2 squares, and then stop. So that's the it's basically the trick. They're working with these clocks. You have your function return a number. If you want it to be rescheduled, return a non-number. I usually go with nil if you don't want it to be rescheduled, and then just manage your conditional logic if you want it to be rescheduled some number of times. So hopefully that makes sense. All right, so next question. Hard left turn here. The third of 4 questions here from yet another student. Working with FFT stuff and true stereo audio files. So I'm still failing to make the morphing with PV rand wipe work with stereo files that contain true stereo information. For example, a morph between stereo guitar and piano stereo recording. I'm not sure if it's possible to do anything like that. It is, but it's a little bit unusual. It's maybe a little bit counterintuitive if you're very used to sort of normal multi-channel expansion stuff. So we've already got the server booted. We'll put that there anyway. And I have prepared 2 audio files. Let's see. I think one is pretty short. This one's just some radio static. And the other one is quite a bit longer. It's the flower pot with a yarn mallet. So the static sounds like this. And then the flower pot sounds like this. Right. And you should be able to see and hear that, you know, I've made these sort of true stereo. I've artificially made these true stereo by just actually changing the left and right channels independently so that they're a little bit different. So yeah, you can see there's different activity going on in both channels. All right, so what we're going to do here is use PV rand wipe to do a random spectral crossfade, or morph, or whatever you want to call it, from one to the other. So we're going to make a synth def. And what we're going to see in this synth def will apply to all PV UGens. It's not specific to PV rand wipe. But you know, so it applies broadly to all of the FFT objects. So we have our 2 time domain signals. Sig without a letter is going to be our output signal. We have our FFT chain. Sorry, this should be a comma. Of our basically the analysis buffers for our 2 signals, and then the wiped signal. You could probably do this with fewer variables. Doesn't really matter. I'm going to be lazy here and just not even bother with buff rate scale. Doesn't really matter. I mean, it's just being lazy. So we have these 2. And then we're going to take the FFT of both of these. And here's where the important step comes in. So normally we just say local buff and then some power of 2 based on, you know, how we want to, you know, the size of our FFT analysis, and then the signal. So this works just fine if it's a monophonic signal, but it's not. It's a 2-channel signal. The wrong way to do it is to make a 2-channel local buff. This will not work. And in fact, in the FFT file, help file for it says these FFT UGens require a buffer to store the frequency domain data. This buffer must have exactly 1 channel. Multi-channel buffers, like the one you see here, are never supported. So, right, it says this will not work. You can't do it this way. Instead, you use an array of as many monophonic local buffers as you need. So they're using array.fill 2 unique local buffers. So that is what I'm going to do. But I'm not going to do array.fill. I'm just going to use a shortcut here and say exclam 2. So this is a 1-channel local buffer, but you know, we're making an array of 2 1-channel local buffers, and then multi-channel expansion can proceed as it expects to proceed. And so the left channel of signal A, there's an FFT analysis done of that, and it's stored in the 0th local buffer in this array of 2. Right? We do this. Actually, oh, it's not going to work. You can't run that outside of the context of a synth def. But it basically looks like this. Right? It's an array of 2 independent local buffs. So the left channel undergoes an FFT analysis and gets stored here. The right channel gets stored here. And then we're going to do the same for the other signal. Right? And now we can go ahead with our processing, FFT processing. So we say chain equals PV rand wipe, chain A, chain B, and then wipe and trig, just to look at the help file for a second. So wipe is something that ranges from 0 to 1, and when it's 0, we have all the bins from A, and when it's 1, we have all the bins from B. And as we move from 1 to 0, from 0 to 1, it randomly replaces bins in A with bins from B. And so it'll basically fill in the spectral data and eventually just construct all of B. So I thought it would make sense to do just like a periodic linear fade from one to the other. So this is a triangle wave that starts, the 3 here is to offset the phase, so it starts at its lowest position. And it does one full cycle over 20 seconds. So 10 seconds to go from 0 to 1, because it's a unipolar range. So the range is 0 to 1. So it starts at 0, takes 10 seconds to go from 0 to 1, 10 seconds to go back down from 1 to 0. And trig, whenever a trigger is received at this input, it picks a new random order in which to replace bins from A to B. And so I thought it would be fun every time we complete one half cycle going from either A to B or B to A to send a trigger so that it picks a new order whenever it does a spectral wipe from one to the other. So we're not quite done. We have to take the inverse, FFT, set that equal to sig. I think I'm going to turn it down just a little bit. Oh, we don't want to do exclam. This is such a habit for me. I always do that, but it's already stereo, right? It's a stereo play buff. We did a multi-channel stereo version of the FFT analysis, and so on reconstruction, sig is going to be a stereo file. And then I just did a little bit of envelope work at the bottom here. So we have a sustaining envelope, and then we send it out. And so now we should be able to play this FFT wipe sound. And so you should hear it morph from radio static to flower pot over 10 seconds by just randomly replacing bins, and then back the other way with another random ordering. So that's the basic process of working with multi-channel time domain signals and passing them through an FFT processing chain. So hopefully that makes sense. Okay, I got one last question, and then I got a special treat for everybody at the end. All right, so this is a great question. Creating a Lush Pad. So this is one more question. The biggest thing I'm working with at the moment is creating a nice pad sound. I'd like to have a warm, full frequency, full body swell of harmonies at a point in my project, but everything I'm coming up with sounds pretty hollow. Been experimenting with sine, saw, and triangle waves at different points, but I'm wondering if I need to be working with more complex waves. Okay, and this student also sent me some starting code, which looks like this. So we boot the server, and it's been basically pared down to start with the simplest kind of sound we can imagine. So we have some arguments. We have a fixed duration envelope and just a basic sine wave panned with the envelope applied. And then there's a pattern. So, random attack, sustain, release. The amplitude starts relatively low, and then as we go, it gets scaled by 0.95. So over time, it'll get quieter and quieter and quieter, but never truly reach 0. So it's just kind of a thing we can stop when we want, and it sounds like this. Right, so it's just a slow arpeggiation of these MIDI notes, getting a little bit quieter each time. Nice long notes, so they all kind of blend together. But they are just sine waves, so it's not as lush and thick and rich as you might want it to be. So some ideas that I just jotted down in comments to keep in mind on ways you can kind of enhance the interest and quality of the sound. Just some scattered ideas here. Instead of a single oscillator, use multi-channel expansion to create a cluster of several oscillators. And this doesn't really do anything unless each oscillator is unique, right? If they're the same oscillator, all you're doing is just adding them together and they just get louder. So using alternative waveforms and alternative techniques. So this person's already kind of tinkering around with triangles and saws. You can filter some noise. You can create some wavetables. You can granulate an audio file. The list goes on. And you could either kind of cram all of these into one synth def or actually make like 7 or 8 different synth defs and then play them all with the same sort of pattern information with multiple p-binds all played simultaneously. Kind of the same result. It just depends if you want to think about having your synth defs as being little modular elements as opposed to one big instrument. Lots of random deviation on all parameters. So you would, put maybe a little bit of random deviation on each individual voice in the cluster so that they kind of sort of, rise to the top and get submerged. Random stereophonic or multi-channel panning. Little bits of distortion on sine waves can go a long way to brightening the spectrum. So there's 3 methods in particular, which can just be tagged onto the end of any unit generator, and it'll do some sort of squashing thing. And just to show you what this looks like, say 1.2 dot distort dot plot. That's too many cycles. Right, so without distort, looks like this. I think even that's too many cycles. So here it is, regular sine wave with distort. Looks like that. Notice it does make the amplitude go down quite a bit. This one's, let's see, soft clip. Looks like this. Amplitude goes down, but not quite as much. And hyperbolic tangent. All slightly different. All kind of sinusoidal. So that's an interesting place to start, I think. You can do a little bit of gentle distortion. And then you can use iteration, so do a block of 3 where you scale the signal up and then distort it and overwrite it, 3 times in a row. So bang, bang, bang. You can kind of layer distortion techniques in series. Low pass filters, maybe resonant low pass filters, lots of filters, SuperCollider, lots to choose from. The primary purpose here is to control the spectral balance. So for low frequencies, you might want to let some higher harmonics come through, but for higher pitches, you might want those to be more mellow and just kind of focused on the fundamental. And then last but not least, just dunk them in some reverb, and that's always nice. Okay, so rather than doing this, I'm going to do a little bits of copy and paste here. So we are going to make synth def. We'll just overwrite the first one. All right, so I'm going to copy and paste the first stuff here. I've added a few arguments. In particular, cutoff frequency and a quality reciprocal for a filter, a second output, and a decibel send value for a reverb effect. And I've added some new variables. So we have our sine wave stuff. I'm going to do a little varsaw stuff as well. which is a UGen I like to use some of the time. We'll do some filtered noise. And I also have a var called freaks. So this is going to be a detuned cluster of frequencies. So here's what I did first. We have our base frequency multiplied by an array of 6 random quadratic interpolating noise generators that range from positive to negative detune, which is a value in semitones, converted to a frequency ratio using MIDI ratio. So freaks ends up being an array of 6 signals, frequency signals, which are all kind of centered around freak, but are just uniquely meandering. This is a technique I've done many times. All right, and then we'll step through this. I'm copying and pasting because I really don't want to, I'm worried I'm going to make a mistake somewhere along the way and then have to spend 5 minutes debugging it. So I am going to paste this in. So now we actually establish one component of our output signal, which is called sig. So we're going to collect over these frequencies, pass each one in, create a sine wave at that particular frequency, right? So the first of these 6 frequency signals, frequency values. We pan it randomly. It's pretty hard panning, almost all the way left, all the way right, some random value in there. And then we're going to do 2 iterations of soft clip. So we're actually multiplying it by a dynamic amount. So it's going to be boosted by some constantly changing value between 4 and 8 decibels, and then soft clip to mash it down and change the shape a little bit. And that'll brighten the sound, bring in a little bit of higher harmonics. You can play with all these values if you want to increase the number of times you do distortion, change the panning spread. You can change, I mean, the detune is an argument, so you can just globally determine how clustery each thing is. And then so what we get is an array of 6 sinoscs, because we return the panned, clipped, not clipped, panned, soft clipped sinosc at the end, and we add them all together. So the result here is a stereo signal, which is the sum of 6 unique sinoscs. All right, then I did almost the exact same thing. Almost the exact same thing. So I reuse this variable. I generate a new collection of 6 random frequencies. And then we're using varsaw with a random phase and a random width. So they're just sort of, they each start randomly in their cycle. And some of them are, actually they're all almost completely sawtoothy. This is a pretty narrow range. You could increase this number if you wanted a sort of a blend of sawtooth and triangle things. But I thought the sawtooth shape was pretty nice. Pan, double dose of soft distortion. I'm using tan H and boosting these even more. Again, just playing with numbers, and then return that. So now we have a stereo signal sig from sine waves, saw, and then a third and final and similar step, another collection of 6 random frequencies, make some pink noise, filter it through a bandpass filter with a center frequency equal to that frequency, and pan it. So now we have sig, saw, and noise. And so I basically do, now we're just tidying up the end here. I add them all together and pass them through a resonant low-pass filter with a user-controllable cutoff frequency and reciprocal quality. I then pass the stereo signal through a balance 2, so I can actually do a global left-right pan, because we are going to be using a pattern to make multiple instances of these synths. So just another panning step to kind of shift the stereo image left to right. It's a lot of signals we're adding up together, so I scale it down here so that it's not crazy loud. Send it out to our direct send and also our reverb send. So where's the reverb? This one I'm just going to copy and paste in. This is a very slightly modified reverb from tutorial 28 called Verb EF, which I made into a pseudo UGen class file. And here I've just converted it back into a synth-def format. So it's stuff that you can find in lots of other videos on my channel, I think. But basically the dry and wet come in, they're the same. The wet goes through some pre-delay comb filters. Normally it's just a single delay with no feedback, and this one isn't here. So this one wouldn't be here. This is like my usual pre-delay, but I decided to make it a little bit funkier and pass it through a comb filter with a short delay and a short decay, and then add it with another one, which has a longer decay and a longer delay. And then it goes through the Schroeder reverb stuff. So comb filters, 16 comb filters in parallel, 8 all-pass filters in series, compensate for any DC bias, low-pass filter for damping, blend the dry and the wet according to the mix argument, and send it out. And I don't know, maybe I'm just irresponsible or careless. I get this a lot. It's a big synthdef. It says retrying via synthdef file. If synthdefs are small enough, they will get streamed from sclang to scSynth. If they're too big for streaming, then sclang builds an actual synthdef file and stores it on your computer, which is what's happening here. But I have gotten in the habit of ignoring these warnings because they're not something you need to worry about. Okay. So performance code. We make ourselves a reverb bus and create the reverb synth, reading from that bus, going out to hardware. I've given it a very long decay and a full mix, right? So it's going to be all wet coming out of this reverb. But that's appropriate because we have this auxiliary send paradigm. So we have a direct path for the dry signal and then a 100% wet path. And I've made a couple of other changes here, which I'm going to try to recap. So I thought it sounded a little bit better with longer attack, shorter sustain. I thought because we're making this cluster, I felt like it would start to sound kind of static if the voices sustain at a fixed amplitude for like more than a second. So I cut the sustain down a little bit. I lengthened the release. The detune value is somewhere between a quarter tone and a half tone. Right, so one would be a full semitone. So just a subtle but noticeable amount of detuning. I added one voice, the previous MIDI note array ends with 80, but I put 92 here just to give it a little bit of extra brightness on the end. The cutoff frequency, it is derived from the MIDI note. So basically, first it just gets the MIDI note, converts it to cycles per second, and it multiplies it by the MIDI notes, again, mapped from an arbitrary low to high onto 8 and 1.1. So the lowest values will have their cutoff frequency scaled by 8. So it'll be a higher cutoff frequency and more harmonic information will pass through. If it's a higher MIDI note, the cutoff frequency is going to be very close to the fundamental, just slightly higher than the fundamental. And then I'm clipping these values to be extra safe between 20 and 20,000. So this just means lower MIDI notes will have a higher cutoff frequency for the low-pass filter, and they'll be brighter and have more high harmonics. The amplitude is also dependent on MIDI notes, so it is doing the usual getting quieter and quieter each time. But it's also, the lower notes are going to be louder. So if we have a really low note around 28, it's going to have an amp of -3 decibels, and the higher ones progressively decrease by 6 decibels. Pretty low quality filter. The panning is random. It's random in the positive range, so it's going to be some close to center or towards the right, but the pattern is going to alternatingly swap the sign of this value. So each successive synth will be left, right, left, right, left, right. This kind of helps guarantee a fairly balanced stereo image. Out direct, out to reverb, pretty high send. So we're giving a lot of energy into that reverb, so it should be a pretty lush kind of sound. And it sounds like this. Yeah, and it's just kind of what I came up with in the moment as I was working on this. If I were to do this from scratch on another day, it'd probably sound quite a bit different. And there's so many things you can change. Uh, I mean, you can try a different type of noise. You can try a different type of oscillator for these two things. You can distort them more aggressively. You can do additional filtering in here. Yeah. And then I also want to comment here that I think part of the solution to making a really, really nice sound is not just being a good programmer, it's also being a good composer. And one thing I'm noticing here is that there's quite a thick cluster of relatively low notes in this sequence. Like there's just kind of, a couple of like semitone, sorry, a whole tone, whole tone, whole tone, minor third, whole tone. And these are all kind of low. These are sort of like tenor bass range. And so I think no matter which way you slice it, the sound is going to sound kind of muddy as these voices kind of pile up on each other, just because there's so much mid-low frequency energy clustered around that area. And we have relatively few high notes. And I think that's part of why I added this 92 up here. And I think very generally speaking, when you are creating some rich cluster chord by specifying frequencies, it tends to sound better if you have sparser but strong low voices that are kind of spaced out. And then as you get higher and higher into the audible range, the voices get more and more clustered together. So like really dense clusters of high voices. Because this is kind of how sound works in the real world. Any particular sound's harmonic spectrum has like the fundamental and the second, and those are relatively far apart. Those are an octave apart. And then as you get up into the spectrum, you have all these like quieter but much denser, more densely packed voices. So I think if you were to recompose this arpeggiation to have like maybe like a 25 in here, maybe two 25s, and just kind of get rid of some of these and focus a little bit more on the mid, high, and high voices, and maybe go up into like the hundreds, 110s if you want. Just be really careful with your mixing, your cutoff frequency for your filter, and how you're going to sort of map the amplitudes based on frequency. I think you can get a really nice sound. I think this is probably the problem area. No matter what I was doing, I couldn't quite get the mud out of the sound here. But yeah, thanks guys. All right, so the last thing I wanted to do, I know we're kind of over time, but I think you'll enjoy this. I did a little exercise just as like a sort of example final project. And I'm just gonna start it up here. Aha. So I made Snake to show you can do kind of more conventional programming assignments, programming exercises in SuperCollider. And we're gonna crash. Right. Okay, so this I put on SC Code earlier today. So you can just go sccode.org/1-5 lowercase e capital R, and you can mess with it. I've tried to comment it pretty thoroughly. I'm basically, it's stuff we talked about last week. I have a user view, and I'm animating it, and it has a draw func down here, and you can sort of follow the logic. Yeah, I'm not going to talk about it since we're kind of over time, but if you do have questions about this, you can send me an email, you can put a comment on the video. But I just thought that was kind of a kind of a silly thing. All right. Well, it's been a fun semester. Thanks everybody for hanging out and watching. And Illinois students, I'll see you separately off stream for final project presentations. I'll send an email reminder at some point. And yeah, guess that's it. That's it for the semester. So I'll upload this code like I usually do. And yeah, I've had a lot of fun. I'm happy with this class. Hope you all had a lot of fun too, learned something. Excellent. Okay, guess that's going to be it. So thank you all for watching. Thank you all for taking this class with me. And yeah, see you all next time.